We're going to look at how substitution applies with definite integrals, because there are kind of two ways that we mess with the bounds when we're looking at it. So there's two approaches here. And so generally speaking, if you're going to change you're going to do use substitution, the bounds must also change. Because in your original function you're using x's, in your new function you're using u. So you can't use the x bounds, you've got to find new u bounds. But you can treat the integral as an indefinite integral, do all the calculations, then just plug in the original bounds at the end. So let's show two examples here. So first, with a boundary change. So in this case, I see my inner function is this 1 minus x squared. So u equals 1 minus x squared. Du by dx is equal to negative 2x. So that means dx is equal to du divided by negative 2x. So I get a new integral of x times the integral of u du over negative 2x, which is the integral of negative 1/2 square root u du. Now the problem is 0 and 1 no longer work because those aren't the bounds I want to work with. So I have to come over and I have to plug these into my expression for u to find what my new bounds are. So u of 1 is equal to 1 minus 1 is 0, and u of 0 is equal to 1 minus 0. So this one's a little weird because it flips them. That's not always the case. That's just how it happens to work out. So in this case, 1 and 0. And so this will be equal to negative 1/2 times the integral of u to the 1/2 times 2/3 u to the 3/2. But because I changed my bounds to be u, these are u values, so I don't have to plug back in the x that I had earlier. So I can just straight plug in at this point. So negative 1/3 times times 0 to the 3/2 minus negative 1/3 times plug in 1 to the 3/2. So that's going to be negative 1/3, or 0 minus negative 1/3, so the answer is 1/3 here. Now, if I want to do this without doing a boundary change, what I'll end up doing is having to plug back in that u substitution order. So we start the same. U is equal to 1 minus x squared. And so instead of dealing with these boundaries, I'm just going to pretend it's an indefinite integral. Du by dx is equal to negative 2x. Dx is equal to du over negative 2x. And so like I said before, now I'm just going to deal with the integral without worrying about bounds at all for the first part here. Square root u du over negative 2x, that's going to be equal to negative 1/2 integral square root u du, which is going to equal negative 1/2 times 2/3 u to the 3/2 plus c. Now I have to plug in my u, which is equal to negative 1/2 times 2/3 times 1 minus x squared. And because I've plugged this in, now I'm back to my original x values. So I can plug in x is 0 and x is 1. So this will be negative 1/3 times 1 minus 1 minus negative 1/3 times 1 minus 0. This whole thing goes to 0, and I get negative 1/3, which is 1/3. So same results as before, it's just whether you want to deal with swapping things over before or after. I bring this up only because in this previous form, there's sometimes AP style questions that relate to this, where you'll have to remember you have to change the bounds, because I'll say like, what's an equivalent using this substitution? If you're going to do a substitution, but you don't actually go through to solve all the way, you do need to make sure these bounds change.